Something's concave up if the second derivative is greater than 0, and it's concave down if the second derivative is less than 0. So let's take this function. I'm going to expand it, put it in like standard polynomial form, because I think that's easier than trying to use the product rule. So I get 6x minus x to the fourth minus 24 plus 4x to the third. So that's negative x to the fourth plus 4x to the third plus 6x minus 24. And the first derivative is negative 4x to the third plus 12x squared plus 6. And then the second derivative is negative 12x squared plus 24x plus 0. Okay, so that's good because that's not too hard of a quadratic. We want to set this equal to 0 to find out where it's concave up and concave down. So if you take this quadratic equation, set it equal to 0, you can solve this one by factoring. So I'm going to factor out negative 12x just to keep my leading term positive. So this is x subtracted by 2. And so there's two solutions, x equals 0 and x equals 2. That means there's two places where this could switch from being positive or negative and vice versa. So let's test x equals 1. And remember, we're concerned with the second derivative. So I'm going to plug x equals 1 into the second derivative. When I do that, plug in 1 in here. 1 minus 2 makes negative 1. Negative 1 times whatever this is going to be, this is going to be negative 12 times negative 1. So that's a positive 12. So it's positive between these two. If I try x equals 3, 3 minus 2 is 1. 1 times negative 36 is going to be negative, so it's negative over here. Then if you try negative 1, this gives us negative 3 times a positive 12, that's also going to be negative. So it's concave up between 0 and 2. It's concave down in two different places, all the way to the left on the number line until you reach 0, union 2 to infinity. And then inflection points are any locations where it changes concavity from being concave down to concave up. Look, concave down to concave up, it's an inflection point at 0. And then concave up to concave down, it's switched at x equals 2. So that's another inflection point.